Ladies and gentlemen, welcome to our webinar on leveraging Unreal Engine 5 for synthetic data generation. I am Tanishka, and on the behalf of Walking Tree Technologies, I extend a warm welcome to each one of you. It is a pleasure to have such distinguished audience joining us today in this exploration into realm of cutting-edge technology. Before we jump into the exciting details of our agenda, let's take a moment to welcome those who are still joining us. For those who are unfamiliar with our organization, Walking Tree Technologies is at the forefront of driving technological innovation. We specialize in conceptualizing and implementing state-of-the-art solutions, particularly particularly in emerging technologies like AI, and now the spotlight is on our discussion, Unreal Engine 5 for synthetic data generation. This webinar is a deep dive into the potential of Unreal Engine 5 in creating synthetic data and its real-world applications. We will explore the fundamentals of synthetic data, provide an overview of Unreal Engine 5, and discuss how controlled virtual scenarios enhance training, specifically focusing on the use of synthetic data for training unmanned aerial vehicles. Throughout the session, we will be aiming to equip you with the actionable insights and strategies that will empower you to harness the full potential of Unreal Engine 5 for synthetic data generation. And at the conclusion of the webinar, we will reserve some time to address your questions and insights. So please feel free to submit your queries in the Q&A box during the session. Let's make this an interactive and enriching discussion. Without further delay, let me introduce our esteemed speakers for today's session. Kicking off our agenda, we are honored to have Scott Seabold, our Chief Technology Officer, leading the way. With an abundance of experience and forward-thinking vision, Scott is the ideal guide for today's exploration into the realm of synthetic data generation. His extensive insights will offer the participants a comprehensive understanding of the role of Unreal Engine 5 and the role it plays in shaping the landscape of synthetic data generation, and how it promises to provide a valuable perspective and strategic insights to our audience. Next, we have Najmu Saqib Shora, our technical lead. He is a seasoned game tech professional with over 7 years of programming expertise. Najma has navigated prominent game engines like Unity and Unreal Engine, showcasing a diverse portfolio spanning XR, life sciences, infosec, and serious games. Participants can expect valuable insights, real-world examples, and an interactive discussion as he shares his wealth of knowledge and experience in the dynamic landscapes of gaming industry. Last but not the least, we have Aditya Upadhyay, our senior software engineer. His immersive hands-on experience with epic games involved training with various studios, guiding him to optimize their pipelines for Unreal Engine. Aditya stands out as a pioneering figure in technology, showcasing a remarkable journey marked by innovation and expertise. Now, as our distinguished speakers take the virtual stage, let's delve into the heart of the webinar. Scott, Najma, and Aditya, the floor is yours to guide us in leveraging Unreal Engine 5 for synthetic data generation.
Okay, good deal. Thank you so much. Thanks everyone for joining. I think today's going to be a pretty cool webinar, a lot of cool technologies that we'll get to see, some nice demos, and a demo from some technology from one of our partners as well towards the end. So hang tight. I think we're going to have a good webinar today. And just to kind of set the stage for how the flow of this is going to go, I'll just give a brief overview of our agenda. And to begin with, we're going to start out with just kind of understanding synthetic data. So we'll spend a few minutes there, and then we'll go into, what is Unreal Engine at 5? What does it do? What are its capabilities? So we'll give you a good glimpse of that. And then we'll talk about some real world applications of synthetic data. And then we'll, from there, we'll go into the different controlled virtual scenarios. And we'll wrap that up with synthetic data for training UAVs. And I think we have a cool demo for that we'll be showing you as well. And then we'll just finish the webinar up with our Q&A time. So with that, let's get rolling on what is synthetic data. And so understanding synthetic data a little bit, and some of you may already be aware. I come from the old school where when we talk about synthetic data, my mind goes to like mocking up data and those kind of things. Well, this goes way beyond any of that type activity that I've done in my past. So synthetic data is, it's this data that's generated through artificial means rather than being collected from real world events. And its primary purpose really is to imitate the statistical properties of authentic data, okay? And the importance of synthetic data in contexts where real data is unavailable, like things like, highly confidential or sensitive areas, or where real-time data is very limited, like rare events or scenarios. And then synthetic data is really crucial in maintaining privacy and security. So especially in industries that deal with that sensitive information like healthcare and finance. And then, synthetic data is really, if you're here for one thing. So we know that synthetic data is becoming a popular thing and really becoming an increasingly important part of this era of big data and AI, because it offers a really viable solution to data scarcity and then privacy concerns as well. So what are some of the use cases of synthetic data? As we look at this, like the role, for example, the role of synthetic data in AI and machine learning, particularly in the training and testing of models where real data might be scarce or too sensitive to use. So it helps in model validation and improving the accuracy of predictions. And if you've ever tried to develop a model, you've already found this out, right? There are cases where there's just no data available because it's too vast, it's too complicated to try to make anonymous. Like I was mentioning back in the old day, we used to have to take data and then scrub what we called scrubbing the data and try to make it anonymous. But then there were even cases where if you look carefully enough, you could even identify patterns within that to have identification type information. So really doesn't work to mock data up in those cases where it's so scarce and where it's sensitive. But with this invent of synthetic data, we can solve some of those issues, right? So in healthcare especially, that's really critical, right? Because a couple of things, if you see some of the uses of synthetic data in like medical imaging, for example, like MRIs or X-rays, those are used, that data is used for research and training without risking patient privacy. So that's really critical in developing, diagnostic tools and medical AI applications. And in the area of financing, synthetic data is used to simulate various economic and marketing conditions for like risk assessment, or maybe you're just trying to validate an algorithm, but it helps really in that decision-making process. For autonomous vehicles, which we will spend a good deal of time talking about today, Synthetic data aids in development and testing of autonomous driving technologies, for example. And that's by simulating various like driving conditions or traffic scenarios, pedestrian interactions. So all those things you can generate synthetic data for, and then use that to train your autonomous vehicle. And we'll speak specifically later about UAVs. So just hang tight with that one. We'll go into that one pretty deeply. And then I would just say, the versatility of synthetic data across various sectors, and that these are just scratching the surface, really, right? We haven't even talked about things like industrial use cases and that type thing. but the versatility of synthetic data across different sectors and its ability to provide practical solutions where real data can't be used is just phenomenal. In terms of synthetic data, specifically in artificial intelligence and machine learning training, the challenge of data availability, like I've already talked about, data availability and privacy in AI and ML training, synthetic data provides a solution to that by offering, really an alternative that's both scalable and diverse. So synthetic data helps overcome biases in real world data sets as well. It allows for the creation of more balanced and comprehensive training sets. And that leads to, more robust and accurate models. And the concept of, generalizability, if that's a word, I have it in my head that it's a word. How about that? It's hard to say though. But the ability of AI models to perform well on unseen data. All right. So it's really synthetic data really provides a wide range of different scenarios. It enhances model generability. So that whole concept of generability is helped realize by using synthetic data. And then synthetic data is significant because in the current AI landscape, and that's, as you all know, that's vast right now, and I think it will just continue to grow. That's especially useful, right, in fostering innovation and reliability in AI and ML applications. So now, we've gone from a phase where AI and ML was just something kind of cool. Companies were trying to use it to now really the applications, a lot of our applications have been integrated with AI and ML. And so the necessity of something like synthetic data to produce data for training our AI ML models is just really, really critical at this point. Well, let's kind of start talking about the crux of why we're here, and that's using Unreal Engine 5. And when we think about Unreal Engine, I know when I hear Unreal Engine, when we first started using it, I thought, what in the world are we going to use Unreal Engine for? We really are not necessarily dedicated to gaming. So I was wondering, well, what can that be used for? And then we started working with a partner that uses Unreal Engine for actually something you'll see later. And what you find out is Unreal Engine is really a useful tool for many different things, right? So Unreal Engine 5, it's a cutting edge tool for creating realistic, high fidelity synthetic data. And it has very advanced graphics rendering capability. So some of the use cases for it are like virtual environments, and you'll get to see some cool demos of that in a minute. Unreal Engine 5 helps in creating realistic scenarios for AI training. So such as in autonomous vehicle simulations. Again, in healthcare, it aids in generating detailed anatomical models for like medical training and simulations. In the architecture field, Unreal Engine is used for visualizing architecture designs in a realistic manner, and that really aids in better planning and design decision-making for architects. The advantages of Unreal Engine in creating synthetic data is really its ability to create highly realistic and detailed environments. And you'll see that in a moment. And Najim, he'll show you that even blades of grass, you're able to see snowflakes on those blades of grass. So really, really detailed environments. And it's also scalable, and it can handle large and complex scenarios. Really, in its versatility across various different industries, it can be applied. So you'll see that in a bit in real world, in a real live demo, I should say. How about that? The idea that Unreal Engine 5 is not just a tool for gaming, it's a very powerful platform for creating really a diverse and realistic synthetic data sets. So what's that going to lead to? I mean, it's going to lead to innovation across multiple fields, because what I've mentioned is just scratching the surface. So looking forward to seeing the uses of Unreal Engine as we continue in this journey. So what I want to do now, I'm going to transition it over to Najim, and he's going to introduce us to Unreal Engine 5. Going to talk about some features for synthetic data generation, and then give us a pretty cool demo. So Najim, I'll hand it over to you.
Yeah, thanks, Scott. Hopefully you can see my screen.
We got you.
Okay, so I think Scott already went through a little bit of the overview of Unreal Engine. So basically, initially it was a game engine. So this is the 5th iteration of the engine. But now, instead of just a game engine, they're calling it a real-time 3D creation tool, because you can do more than just build games with it. And it's used across multiple industries. It's still used in game development a lot, but it's also used for film, TV production. It's also used in simulations, which is what we're going to talk about primarily, and obviously synthetic data generation. It's very well suited for high fidelity photorealistic simulations, because you can get really nice detail, and it will perform well. It will perform very nicely as well. And it has features such as Nanite and Lumen, which you won't find in any other real-time engine, at least as of now. And there's also like good features for developer collaboration, like one file per actor and multi-user editing. We talk about that a little bit as well. Yeah, so first off, Nanite. What is Nanite? So basically, it is a, I mean, at the end of the day, it's an auto LOD system. So what we used to do is that we used to create multiple LODs, discrete versions of a single static mesh, or you could say a 3D model. And then it used to load in based on the distance from the camera and how much space it's taking on the screen right now. But Nanite it's more continuous in terms of like basically it's not discrete like creating a bunch of LODs, like a finite number of LODs. It's more continuous, and also doing it automatically, and that makes it really convenient. And also we can render millions of polygons this way. We're able to get in cinematic quality assets and render them very at a very nice frame rate, even on laptops. Like I'll be demoing whatever I show on a gaming laptop. And Lumen is basically their real-time dynamic global illumination and reflection system. So basically, which means that you don't have to bake your lights anymore. You can just change lighting in real time and see the effects happen as well. Like this, I mean, that used to be the case with direct lighting always, but now we can also do it with indirect lighting, which is the main point here. And the thing is, Lumen works in two ways. So if your machine can handle hardware ray tracing, so it will just use ray tracing behind the scenes, basically use your hardware. But if it doesn't, like it's a lower end hardware, then it does an approximation of the mesh. So it will create something called sign distance fields for the mesh, and then it will use that, and it will basically do a software ray tracing instead of hardware ray tracing, and it will be performant as well because it's using an approximation of the mesh. And there's also Datasmith. So this allows for seamless import into Unreal. So they have exporters for multiple DCC tools, and you can export to a Datasmith format and then bring it into Unreal that way. So nice interoperability you get with this. And Blueprints Blueprints, they are a system which allow you to prototype very quickly, and the compilation times are very quick. So you can in fact use Blueprints also in production code if you want. Like there's a time maybe you might want, okay, I want more performance out of it, you might say, then at that point you can move it to C++. But it's also used in production code in a lot of projects. And yeah, it really shines in when you have to prototype something new, because it's really quick. And yeah, apart from that, Unreal comes with a really nice physics engine. They have something called the chaos system. They have the chaos destruction, chaos vehicles, chaos cloth. So basically, all these are physics systems which allow you to simulate real-time physics. And destruction in particular is really nice, and you can do real-time, but you can also bake the simulation, and then you can sort of scrub through the timeline. So if you want to basically just bake the destruction, basically do the destruction beforehand, and then you can store the results. So you can do that way as well, depending on what platform you're targeting. And obviously, there are other things to consider as well. Unreal has a very nice game AI framework, but you can also hook in your own third-party plugin or third-party code, basically, with their AI framework. So it'll be like their thing at the high level, but it'll be interacting with your third-party code, basically. They also have there's a MetaHuman Creator is a separate tool where you can create basically photorealistic human beings, and they are fully rigged. And they have so now Epic Games, who basically owns Unreal, they are coming up with a lot of cool features for metahumans. So recently they announced MetaHuman Animator, which allows you to easily animate these guys. And then the import of a metahuman into Unreal works out of the box, and it's really nice. So you can easily get photorealistic humans without requiring a DCC. And also, yeah, if your target audience is on a web browser, you can still use Unreal, and you can use something called Pixel Stream. But essentially, this is like a cloud streaming technology. So your application can run on a server somewhere, and it can stream to a user's web browser. It can be on a PC, it can be on a laptop, it can be on a mobile phone as well. And then virtual cameras in Unreal, they actually mirror the real world cameras, and that's why it's used a lot in, like I said, film industry. And these are not toys. The settings on these devices, they are actually industry standard, and yeah, there's a lot you can do with that. And yeah, multi-user editing is a feature which allows multiple people to join in a session and then work on a same level, which is really nice. And one file per actor. So basically, what used to be the case with, I mean, working on, I would say, games in general, because we work mostly with binary, right? We don't work, I mean, obviously, if there's code, there's text, but apart from the code, like a lot of things happen using binary files, right? We deal with binary files a lot. And so people use Perforce and stuff like Plastic SEM mostly. And the thing is, when people are working on a same level, what they used to do is split the level. So that was, I mean, it was, I guess, a workaround, but what one file per actor allows you to do is that it can basically, you can do that the same thing, the split, you can do it on an actor level, or basically like a game object level, right? On an object level. And that is really nice, because now if someone checks out like a undetermined area in a level, like so basically he can work on that, and other people will obviously not able, they won't be able to basically sort of check out the same thing because it's already checked out. But this way, you get more control because of this granularity, and it's obviously a lot more convenient. And yeah, finally, you can add your own third-party code. So there's a nice support for plugins, and it has a very nice extensible architecture. And now I'm just gonna show a small demo. We're going to revisit the scene that I made. So I made this basically using stuff that is available out of the box. Apart from the ultra dynamic sky, everything that you see here is part of Unreal's basically out of the box features. So yeah, so the assets that you see, they're actually mega scans. So they come with Quixel. So Quixel Bridge is actually available in Unreal Engine now, and everything that you see here is basically free. And so I was talking about Nanite, right? So this guy that you see here, right? So you see like there's a couple of rocks here. So this guy that I've selected, you can see like it's made up of all these rocks. And each of these rocks, like each of these, like there's a couple of them, right? Each of these, like one single rock is 3 million triangles, right? And which means like we're looking at like a ton of triangles right now, like millions of triangles right now. And you can see like I'm getting a really nice FPS, like very nice frame rate. And yeah, I mean, I'm using Nanite for the grass as well. Like these small rocks that you see that are painted, like there's like a ton of these small rocks, right? Each of these small rocks is actually 1 million triangles. And this is not possible in any other real-time engine. Okay, as far as I know. I mean, as of now, it's not. Okay, this is only possible with Unreal's Nanite technology. And this scene is being lit dynamically with Lumen, which also allows us to, make changes to the lighting. For example, we're going to revisit this, but for now, I'm just going to change it to, like, let's say, like a bright sunny day. And you can see it updated the lighting in real time, right? So that is possible because of Lumen. And like I said, like everything is Nanite, this grass is Nanite, and yeah, this grass looks great, as you can see up close as well. And look at the rocks look great as well. And this is all free assets. And so landscape, I made using the landscaping tools. The water system also, Unreal's own water system I'm using. I have not changed the material, it's the default material, but you can actually do that as well. These ferns are also mega scans. They are also animating a little bit, you can see. Yeah, I can actually show one last thing. So I'm just gonna go into triangles more. You can see like everything is Nanite. And if I take a look at the rocks, now why did I put the rocks? Rocks. Might have to actually, wait, hold on. Oh, there. Let's take a look. All right, so you can see, like it almost looks like it's static noise, right? But it's not, it's actually triangles. The density is crazy, right? The density of triangles that you see here is crazy. And this is possible only because of Nanite. The fact that you're able to get this much detail and with such high performance. So this is possible only with Nanite, only on Unreal. So yeah, with that, I think I'm gonna continue and I'm gonna let Aditya take over from here. Aditya?
Thanks, Sajam.
Yeah.
Hey everyone. Today let's dive into exciting world of Unreal Engine 5 and how it helps businesses create incredible virtual spaces that look and feel real. Think of it as crafting your own world on a computer screen. I'm going to share some cool features with you today. Making realistic landscapes. Ever wanted to create virtual landscapes that looks like just real places? Well, with Unreal Engine 5, it's a breeze. This engine comes with tools that lets us build environments that are stunningly realistic. Whether we have an artist designing it or we use specially geologically accurate data for synthetic data generation, these tools turn into virtual world into something truly amazing. Creating different things automatically. Now, let's talk about making our virtual world interesting and unique. Unreal Engine 5 comes automatically create to create different things for us, like mountains or buildings. This way, we can keep our world exciting and full of surprises. It's like having a brush to make things cool without a lot of extra effort. Building things faster. Imagine you want to add lights or cool objects into your virtual world. Unreal Engine 5 has this awesome feature called blueprints. It's like having a set of supercharged building blocks that helps us create things faster. We can reuse these blueprints, making our work speedy and well organized. It's like having a shortcut for building awesome stuff. Loading and unloading parts dynamically. As our virtual world gets bigger, we need it to run smoothly. Unreal Engine 5 can do something really smart. It loads or unloads parts of our world as we need them. This keeps everything running fast and makes our virtual world feel alive. Just like in our favorite video games. It's like having a wand that keeps everything running smoothly. And lastly, mixing and matching different parts. When we are building our virtual world, we can mix and match different pieces. It's a bit like playing with Lego blocks, but for our virtual world. We can be creative and make our world look awesome, all while keeping everything organized. It's like being the architect of our own fantastic virtual universe. So, Unreal Engine 5 is like a superhero for businesses, making it super easy to create amazing virtual worlds. We can make it look real, add cool surprises effortlessly, build faster with blueprints, run our world smoothly, and be creative with mixing and matching. It's like having a box of magical tools to bring our virtual dreams to life. Alright, now changing things easily. Imagine you have a virtual tree or a whole digital city in your magical world. With Unreal Engine 5, it's like having a special artist configurable palette called Blueprints. What's that? It's a tool that lets us easily tweak every little detail, making our digital world uniquely ours. It's like having a superhero ability to customize everything to perfection, making the weather and lighting perfect. Now let's talk about settling the mood. Unreal Engine 5 gives us the director level powers with special tools for weather and lighting. If you would like a sunny day with a gentle breeze, sure. Or maybe a bit of dramatic rain for that mysterious feel. Yeah, that's also possible. Unreal Engine 5 has got our backs. It's like being the maestro orchestrating the perfect scene to make our digital world come alive. Now, creating different landscapes easily. Let's dive into the creative zone. Unreal Engine 5 makes it easy to create different types of digital landscapes, from hand painted to real life landscapes. It's like having a paintbrush that effortlessly transforms our digital canvas. With just a few clicks, we can conjure up diverse terrains from mountainous landscapes to futuristic cityscapes or GIS or geologically accurate data geotiff. It's like being a digital Picasso, painting a vibrant masterpiece. Alright, easy ways to switch between digital worlds. Let's talk about flexibility. Sometimes we want different things and different versions of our digital worlds. Unreal Engine 5 makes this as easy as flipping through your favorite storybook. Imagine having a bunch of bookmarks that teleport you between different scenes in your digital world. That's what Unreal Engine 5 offers. A seamless way to switch between digital realities effortlessly. So, Unreal Engine 5 isn't just a tool. It's our secret sauce for creating mind-blowing digital experiences in business. Whether we are fine-tuning the tiniest details, orchestrating the perfect weather, painting diverse landscapes, or seamlessly jumping between different digital worlds, it's all a thrilling adventure. And for the same thrilling adventure, Najam, please take the lead for showcasing another demo.
Yeah, thanks, Aditya. So let's revisit the environment I was showing earlier. Hold on a second. Gaming laptops. All right. So, so this was the scene that we're looking at earlier. So on the topic of creating controlled and diverse environments, right? We are using a sky and weather system called a dynamic sky. There's another one which is also quite popular, but this is the one that we're using. It's pretty good. And if you want, you can also use Unreal's inbuilt atmosphere system. The weather system, as of now, I mean, it doesn't come out of the box, but yeah, there's a couple of options. So if we take a look here, we have some sliders. Basically, these are some variables that we can control. If I adjust, let's say the cloud coverage, suddenly it's really bright, it's a bright sunny day. We can remove all the fog. We can, what else can we do? Let's see. Oh, I think we can do more in the other guy. Yeah. So we can remove the material wetness. All right. So now it looks, I guess, as it should in a bright sunny day. And basically, you can see like these are sliders that we are changing. These are numbers essentially we are adjusting. And using basically this control, you can easily create a control, basically a scenario that you want to for a certain synthetic data session, synthetic data generation session. And we have some presets available as well. I'm just gonna show you how different the same scene can look in different settings. basically, let's start with the clear skies preset. Again, these presets are basically just a collection of the same variables that I showed you. Just some preset values that are saved as collection. So I'm just going to go with the first one, which is clear skies. So I can show the contrast better. So clear skies, you can see everything is dry, and yeah, we got sun and everything is nice. And if we basically go to another extreme, we can see the same environment, how different this looks. And these rocks, now they're covered with snow. It's not just particle systems that you see, like it's not just the snowfall that you see, which is also very nice actually. So this is actually Niagara, which is Unreal's particle system framework. You can see the snows also on the ferns and on the grass blades, right? And these guys are dancing. So there's a strong wind blowing. And yeah, so you can also, I mean, if you don't want to go that extreme, you can also do like a slight snow, right? So now the snow doesn't cover the ferns entirely. And also the landscape is somewhat visible. Likewise, if you go to rain, the rain preset, you can see the wetness on the landscape, on the ground here. Yes, so you can see the particles hitting the surface, creating these nice effects. You can see the wetness on the rock as well. And yeah, so basically, yeah, the same environment can look different and you can control this. That's the main point. So this allows you to do different sessions. Essentially, you can change seasons. You don't have to wait for the seasons to change in like you do in the real world to collect data. You can do that very easily here. And you can also do like a thunderstorm. So if what we can do is just play. I can show you. This also comes with sound effects, but yeah. So you might be able to see, yeah, we got thunder as well. So yeah, that looks really nice. And yeah, so essentially that's the idea. You can create, so you can use the same environment and you can control the appearance and achieve, so you can do multiple standard data generations using the same environment. And Unreal has recently come up with a new feature called the PCG graph. So that's procedural content generation graph. And you can do a lot more with, I mean, a lot more than just seasons. Maybe we do a webinar and next time we'll show that. Basically, it allows you to very nicely create variations, not just in terms of weather and seasons, but also in terms of the landscape. So yeah, at this point, I'd like Scott to take over. Thanks, Scott.
You got it. Thank you very much. And so now you've gotten a little glimpse at Unreal Engine and some of the things that it can do. And so this next session, or really section of the webinar, what we're going to talk about specifically is about synthetic data in training UAVs. So we'll talk about UAVs and AI and ML. We'll talk about UAV training with synthetic data. And then I think you're going to get to see a really cool interactive example that Najim will take us through later using some models from one of our partners, Scaled Foundations, and their AirGen product. So a really cool section, I think, coming up, another cool demo. But let's kind of set the stage for that. If we look at UAVs, right? What are UAVs, right? Unmanned Aerial Vehicle, right? So, or otherwise known a lot of times as a drone, right? They have the capability to autonomously work to operate autonomously without a human pilot on board. So UAV technology is really rapidly evolving and has evolved rapidly. And these vehicles are now utilized in a wide range of industries and applications. UAVs are diverse. They come in all different shapes and sizes, and each one is designed for specific tasks. Some are small and agile for really intricate photography type applications, while others are larger and even equipped for cargo delivery. So the diversity allows UAVs to be really highly versatile, and from capturing stunning aerial photography to performing critical surveillance type operations, right? So let's kind of talk about some of the applications. And again, I'll talk about some. There's really vast and broad applications for UAVs, but specifically around like aerial photography. Drones are widely used in film and media, like Najim was saying earlier, and they're used in that industry to capture high quality aerial shots that were previously difficult or really expensive to try to capture. And if you watch the film industry over the years, what would that take? I don't know, a helicopter, getting something really high. Anyway, it can be really difficult, and even some level of I hesitate to say unsafe, but difficult for humans to do, right? So now with this type of technology, you can get those overhead shots really very easily with a drone. Surveillance is another application. So the use of drones for security and monitoring purposes, that provides real-time data in situations. And then another big use case for it is mapping, right? So drones revolutionize mapping by providing up-to-date, high-resolution images of geographical areas. It's useful in urban planning and disaster management. And then, we talked about the cargo carrying capabilities. It's also used to deliver goods. So UAVs are being used in logistics to deliver goods, especially in like remote or difficult places to access. And then, we've talked about this a little before too, but in disaster management, right? So it plays a critical role. Drones play a critical role in disaster response, where they assess damage, locate victims, and deliver emergency supplies. Now, what about AI and ML integrated with UAVs? So, I'd really like to emphasize the role of AI and ML algorithms in processing the vast amounts of data that's collected by UAVs. So you can imagine we'll see a demo that does just that, and look at all the data that's being gathered as a UAV or a drone as it flies around, right? So there's tons of data, and AI enables us to do real-time data processing with that, which is really essential for applications where immediate and autonomous decision-making are required in the field. Capabilities like object recognition, for example. So you got these nice high-fidelity cameras on these drones, and being able to use synthetic data, as we'll see, is really critical there, because we don't have to necessarily fly a drone. We can use these environments to be able to create data and train those drones without having to send them out and doing things that might result in an issue for a real drone if you were trying to design it under real world circumstances. So capabilities like object recognition allows drones to identify and classify objects within images, can track, and all those are used, right, to follow moving objects. And for something, let's imagine, if you're trying to follow and study wildlife migrations, for example, right? And really, I'll just say too, that AI ML is revolutionizing industries with UAVs. So it's really had AI ML on UAVs have really had a transformative impact on applications, particularly in things like agriculture. I grew up kind of in a farming area, and who knew that one day we'd be able to use drones for agriculture purposes. But drones can monitor crop health, they can track growth, they can even assist in planting and harvesting. Search and rescues, we've talked about before, that's a huge area. Drones with AI can quickly scan large areas. They can detect heat signatures. They can identify people that are in need of help, for example. And then there's environmental monitoring as well. So use of drones in monitoring environmental changes like deforestation, water levels in reservoirs, maybe the health of marine ecosystems, for example. So a lot of varied purposes, and that's not to mention some of the industrial purposes for that as well. So just to kind of conclude this slide, the future potential of UAVs empowered by AI ML is really just a huge advancement. And really, as we continue, and as you see this next demo and what AirGen does for us, just the advancements that we're seeing, making UAVs smarter, making them safer and more reliable. And then really, it's we're continuing to innovate in that space too, right? So continuing innovation, AI, ML to enhance the capabilities and the applications of the drone. So, that's that innovation is just going to ensure that they remain a vital technology for modern challenges. So we'll see that. I really believe we'll see the growth of using UAVs with AI powered. We'll just continue to grow. Well, let's talk a little bit about UAV training and synthetic data and generating with synthetic data. UAV training with synthetic data. So what are some of the benefits, right? So it's really important using synthetic data in UAV training. Synthetic data offers a really cost-effective but also scalable solution for training UAVs. So synthetic data reduces the need for costly world flight hours and physical materials, which in turn minimizes the financial barriers to extensive UAV training programs. So it makes it much more affordable and a lower entry to market. Cost effectiveness and scalability, like I've said, the economic benefits of synthetic data and training these UAVs, such as, say, the reduced need for physical prototypes and the ability to simulate those. And I talked about this a little bit ago, but the ability to simulate those expensive sensors and cameras, right? And in terms of scalability, think of it like this. And you saw the demo earlier from Najam. Once you create a synthetic data, a synthetic environment, it can be reused repeatedly for different training scenarios without additional cost. So you saw where he was changing lots of different variables in that environment, right? But he wasn't creating a new environment for each of them. It was using the existing environment and simply changing some variables to enact different change on that environment. So really provides scalability because you can reuse it. Well, what about safety and risk reduction, right? So the safety benefits, synthetic data allows for really risk-free training in complex and dangerous scenarios without endangering the equipment or even more so personnel. And again, examples of that we've already talked about kind of is training for emergency response in disaster zones, or navigating in hostile environments where real life data would be impractical or perilous for that matter. So, as we look at this, look at the different scenario generation, it really allows us to have a more controlled and diverse scenario generation. So synthetic data, it enables the generation of diverse training scenarios using UAV systems, so UAV systems can really cope with a wide range of situations, right? So you can use the synthetic data to kind of do the hard part there, so you don't have to go out and try to train your real UAV to do things while you're crashing it, damaging it, and having to replace it with other, with expensive UAVs and, the sensors and the cameras that go along with it. So, these scenarios can be controlled and they can be manipulated to include specific changes, like I was saying earlier, specific changes or variables that a UAV might encounter. That really enhances the thoroughness of the training, so that when you really deploy your drone to do whatever task it is, it's already been trained to handle certain situations, right? So just like airline pilots, they go into simulators and they have to go through, they'll throw them different scenarios, right? So they're training to be able to handle those scenarios when they come. Kind of the same kind of concept, the way I see it there. So, what are the challenges, right? What are the challenges in the future? So really, despite all the benefits, there are hurdles to overcome when we're talking about really integrating synthetic data with UAV training. And that really is because there's a gap, right? The gap exists between the synthetic data and real world. So it's important to ensure that when we're talking AI and ML models, that they are trained on synthetic data that perform well in real world conditions. And you'll see, to bridge that gap, you've got technologies and got companies like like Scale Foundations and this AirGen that they develop these foundation models that really help in really closing that gap. And those are just going to keep getting better and better and better. Well, what about ongoing research and development, right? There are definitely lots of ongoing R&D efforts in the field of synthetic data generation. And the aim of that is to really make it more realistic and applicable. Things like, think about advancements in computer graphics, right? It just seems like every other week we see something new coming along in computer graphics, in AI and machine learning. And those are really being enhanced. Those are really going to enhance the quality of synthetic data. So it's only going to get better from here, and it's already great. And I would predict, that one day I envision a future where UAVs are really adeptly trained with synthetic data, and that's going to result in more efficient, safer, and really more capable aerial type systems. Okay, and with that, I am going to turn it back over to Najim, and he is going to show you a pretty cool demo, and then we'll get things wrapped up. So over to you.
Yeah, thanks, Scott. Just give me a second. All right. Hopefully you can see my my code editor as well.
We got you.
Yeah.
All right. Nice. So, all right. Okay. Okay, there was one more thing I needed to do. Sorry, guys. All right. So, actually, yeah, before I start, so what I was showing you, essentially, this is a static digital twin of Tokyo. Essentially, what that means is that it's a snapshot in time of Tokyo based on real world GIS data, and we can add dynamism to this. Like, for example, the easiest way to do that would be, I mean, not maybe the easiest way, but one of the ways to do it would be get real-time traffic data and then simulate cars running on these roads. And then, dynamism in the spectrum, you can do more or less as well. But as it stands right now, this is a static digital twin. And we are using Cesium for this, and it's actually getting these 3D assets from Google, so using Google Maps API. And so these assets are very good for macroscopic simulations, I believe, because if you take a look at these guys up close, they don't look very good up close. And I would recommend the earlier approach that I showed you for something like that. But for a UAV sort of a training scenario, I think this works pretty well. And we're going to actually demonstrate that. So yeah, with that said, so we'll be using AirGen, and we'll be using another plugin. Basically another platform called Rerun for actually capturing the data. So let me play this guy. So the tiles will start to stream in there. Like I said, they're using Google. They will be streamed from the internet. And I'm going to run my script. So this is the Python API for AirGen. And basically what this will do is that, hold on, let me use the first person view. So essentially what will happen is that what is happening right now is that the drone is going to some random points in space, or you could say geodetic locations. And then it will, as it's doing it, it will also capture synthetic data. So right now, I'm doing very basic stuff here, like I'm capturing the depth perspective and the RGB data, but you can do more. You can do more. And
Najam,
yeah,
we are
sorry.
not able to see the rerun window.
Oh yeah. Sorry. I have to share that separately. Just give me a second.
Sure, thanks.
Thanks. Can you see it now?
Yes.
Okay, wonderful. So yeah, this was the rear window I was talking about. So right now it's just RGB and depth perspective, but you can do more. And right now the drone is going to some random positions and collecting data, but you can actually specify geodetic locations like lat, long, altitude, and the drone will go there. It will capture data there, and basically you can also orient it, so you can also specify the rotation. So essentially, you can specify a bunch of waypoints. So the drone, as it moves through the waypoints, it will collect data. So yeah, that's possible as well. And yeah, good thing about this rerun platform is that you can scrub through the data that you've collected, which is nice. And you can also go to obviously the latest. And while this is running, Scott, I think it'll be good if you can, contextualize this a little bit. Like one example I can give, like why this would be useful, I mean, apart from the obvious UAV training is, for example, if you have a generative AI model and it requires uh, images of cityscapes, so I think, yeah, this is a nice way to kind of get that data. Yeah, but over to you, Scott, if you can. I'm just going to share my
No, I mean, if you look at kind of what goes on here, right? Everything that's around you, if you're need to gather data, like you said, on the cityscapes, maybe you need to know how to navigate things like towers, right, for communication, or it could be cases where, with a UAV, maybe not so much, but like in training autonomous vehicles, for example, you could look at traffic patterns and you could simulate, what happens with different times of the day, even with the UAVs, right? You could simulate what happens at dusk and at this situation, right? Maybe it's cloudy, maybe it's raining or snowing. Maybe you've got a lot of sunshine. So how does the UAV really react for different conditions, right? And that helps us in training our UAVs, or AI for our UAVs, because then you can start to know what to do. Well, what happens when it's raining, or what happens when the sun is glaring here or there at a certain point, right? What happens when I come across a tower to avoid collisions and so forth. So yeah, lots of different data points are gathered here, and with with what we're seeing here, especially with the foundation model that you're using to help simulate this environment and generate this synthetic data, there's lots of really rich data that's being recorded here, right? So now you can take all that data, and instead of you having to go out and use a real UAV to learn about all these things, now you've got this synthetic data that you can use to train your real equipment on. So save time, save costs, saves possibly crashing this drone that could cost thousands of dollars, right? So hopefully that helps.
Yeah, thanks, Scott. Thank you. That was helpful. Yeah, I think this brings us to an end, at least for now.
Be cool. Over to you, Tanishka.
So before we wind up, let's skip to the question and answers. I can see a few questions in the Q&A box. Now, the first question we have received from Alex. Alex wants to know, what methods does Unreal Engine 5 employ to ensure the accuracy and consistency of synthetic data?
So yeah, I think I can take that a little bit, and maybe Scott then
Okay.
you can
I'll
follow
take
up. So basically, Unreal Engine in itself is not for synthetic data generation. I mean, it's not like it's designed for that particular use case. You can basically add it to your set of tools. So what I was showing, basically AirGen and Rerun.io, those are the platforms actually, that actually do the synthetic data generation in terms of the actual, I guess, from the implementation side of things. But yeah, I guess in terms of accuracy and consistency, do you want to talk about that a little bit, Scott? Like how do these platforms usually do it?
Yeah, I mean, let's see. Let me make sure. Can you hear me? I can't remember.
Yeah.
Okay, I did. Good. So yeah, I mean, the methods that you would use to make sure the accuracy of what of your synthetic data. I mean, a lot of these environments are going to be scrubbed, right? They're going to be created. They're going to be used. They're going to be looked at, and especially in cases like what you're just looking at too, beyond even Unreal Engine 5, you've got these foundation models with the drones that have been vetted and trained. So that itself, just on how the drone works, even within inside Unreal Engine, right, is getting really good data that's been trained and really modeled from real world. So those models that are being used even inside what you're doing there help vet any inconsistencies, and they kind of close that gap, like I was saying. So they increase the accuracy of that. And that gap that I talked about, right? The challenge is with this is always making sure what you show there is really what the real world situation would look like, right? So the example you showed, you were using Google Maps, right? So what would be a way to even better represent and get more detail, right? You would have to make sure that what you're looking at is coming from something a little more high resolution. So something you might have to develop within Unreal Engine itself, right?
Yep.
Yes,
Hopefully
Scott,
that
thank
answers
you.
the question.
Yep. Next question I can see we have received from Sarah. She wants to know, how does synthetic data generated by Unreal Engine 5 integrate with existing data analysis or machine learning pipelines?
Yeah, I would say, it's used, can be used for like the data generation itself and data generation preparation. Things like pre-processing for compatibility, model training and validation. It can be used in model development and really in the operations, and then, the technical operations integration as well. So, if we break each one of those down, right, if we look at like data generation and prep, you think about the creation of synthetic environments. So using Unreal Engine 5, developers can create a realistic three-dimensional environment that mimics the scenarios in which AI models are being trained on. And things like simulation of the scenarios. These environments are then once they're created, these environments are then used to simulate various scenarios that generate the synthetic data needed. So it can be used in the simulation of the environments can be used in the simulation. You can change variables, parameters around that environment. And then for data, like data export, you can see we were capturing that synthetic data there. That data generated within Unreal Engine 5, it could be images, videos, sensor data, so on and so forth. And that can be exported in formats that are compatible with machine learning frameworks like a CSV or tabular data, or like, HDF5, PNGs, and so on. So yeah, I mean, and in terms of like that compatibility, data cleansing, data transformation, feature engineering, it can be used in all those different situations as well, like data cleansing, for example. Any noise or irrelevant information in synthetic data can be removed is removed to increase the quality of training, of this whole training process, right? So yeah, I mean, it's when you think about it can also I don't know, it can in terms of machine learning models, it can be used to and transformed really into like structures or formats that are expected by machine learning models, like like tensors or neural networks and that type of thing. So yeah, just that whole process, really, you can use this data pretty much throughout that whole throughout the whole data analysis and machine learning pipeline.
Sure, Scott. Next question is from Eddie. The question is, what is the scale of data that can be generated? Is it suitable for large-scale projects?
I would say that it's very well suited for large scale projects, more so than any other kind of technology that we've seen yet, right? Because we're using machines to generate the synthetic data, so they can generate large amounts of data varied across lots of different scenarios, really much quicker in more accuracy and fidelity than we've ever been able to. So I would say that it's definitely well suited for, for large scale projects. And if you think about just the scale of the data that's needed to train UAVs or to train autonomous vehicles, the scale of those is really massive. So yeah, I think it's very well suited. And without going into a lot of detail, I would say the answer to that's yes.
So Aiden wants to know, what are the limitations of synthetic data generated by Unreal Engine 5 in regards to accuracy, fidelity, and
I don't know, Najim, or if you want to try to take that one.
I would say, so I would say, I think it depends on the environment that you've created, and also whatever lighting and weather systems that you're using to simulate the seasons, the climate. So, for example, like I said, this environment right here, if we take a look at it at a high level, like this looks pretty good for, I would say, like I said, like macroscopic data generation, standard data generation. But if you go up close, yeah, it doesn't look very good, obviously. So taking this to I mean, generating data from this angle, I mean, up close, and then taking it into an AI model to train it, I wouldn't say like that would really help, right? So, so again, for this, I would say the better use case would be something that requires, I guess, like I said, images of cityscapes, something at a macroscopic level, or maybe you're doing something else. Maybe just want to train the UAV in terms of collision avoidance or path planning, or you want to train UAVs in terms of like, so basically how to do deliveries in a city. But the other environment I showed earlier, right? This one is well suited for doing stuff at a I guess you could call it microscopic scale, but basically stuff at a ground level, you could say. So obviously this looks very realistic, and I would say so depending on how much time you spend with this and how well you craft it, it would look indistinguishable from real world data, a real world environment, I would say. In fact, if you take a look at the rocks here, these are essentially photogrammetry assets. Like these are not modeled even. Like these are actually taken from the real world and then just put in the engine. So basically, yeah, I mean, it depends on in terms of, I would say, the accuracy as far as the quality of the images are concerned. I would say that depends on how well the environment has been built, what kind of assets are you using, and what use case you're targeting. Like, so do you want images of ferns or small rocks? Then obviously, yeah, you need to do a little more work instead of just getting some GIS data, right?
Yeah. I think it kind of goes back to what I briefly talked about too, just that gap that exists between the synthetic data and the real world. So that's kind of, and I look at it almost not like a limitation necessarily, but it's just a challenge to overcome that gap, right? And what you can see is that gap is quickly closing. So, but that's the concern. Not necessarily, I would call it a limitation, but it's just a challenge that we have, is to try to get closer and closer and closer to, to the real world, right? Just like that Google map you saw, There were certain, when you tried to zoom in, you started to get kind of pixelated. You couldn't really tell what's what, right? So it really depends on us and how closely we can get it to represent a real world situation, right? And you could also run it to, I would think, some issues, even though it's got a very good physics engine, you might also run into some physics type issues, right? With maybe the real world physics don't quite match, especially when we're talking about like things like, human interaction and those kind of things. But it does a pretty amazing job as it is. But there might be some limitations there in what it can process. But I can tell you that physics engine is pretty darn good. And it's like, even like we were saying, the real world versus the synthetic data, and then trying to close that gap. I just think that'll continue to get better. But you could run into situations where, okay, not quite there, but stay tuned, because there's updates to Unreal Engine all the time. So.
Yeah, and also computer graphics technology, it keeps rapidly improving. Yeah. So now we can do real-time ray tracing, which was not possible a couple of years earlier. I guess, I mean, it was possible, but not at this kind of performance. And getting in, like I said, what Nanite allows you to do is bring in photorealistic models with triangle counts in terms of millions, right? So that was not possible, definitely not possible a couple of years ago. So now we can do that. So yeah.
Yeah, and I guess the only other thing I would think of too is things like things like bias, making sure you don't inadvertently bring bias into your environment. That from the real, some even real world type examples too, right? And then things like things, and again, it's not necessarily a limitation, but a challenge, and things like regulatory compliances. For certain applications, especially like safety critical domains, there may be regulatory challenges in validating and really certifying AI models trained on synthetic data. So you may run into those situations as well. Limitations, we could call it a limitation, maybe. I think it's really more of a challenge that we have to overcome. So I think those areas and those gaps are closing pretty quickly.
Thank you, Naj. Thank you, Scott. Thank you to all our speakers for sharing your invaluable insights. It was indeed a great session knowing about Unreal Engine 5. And a heartfelt thanks for each one of you for being a part of this webinar. Before we conclude, mark your calendars for our next webinar scheduled for 22nd of February, where we are going to explore comprehensive evaluation strategies and tools for LLM applications. I will be sending invites to each one of you. Until then, thank you all for your active participation. Stay tuned for more engaging discussions in the future. Thank you.
Thank you.
Thank you, guys.
All right. Thanks, everyone.